Welcome to the conversion factors activity video. Conversion factors are derived from equalities. Equalities describe the relationship between two different units. 1 meter, for example, equals exactly 1,000 millimeters. These are both within the same measurement system. Or we can compare between two different measurement systems. For example, 2.20 pounds, pounds are the US system, equals approximately 1 kilogram. And this is in the metric system. Using the equality that 60 minutes equals 1 hour, we can create two different conversion factors. These conversion factors are ratios. We can say there are 60 minutes per 1 hour, or there are 1 hour per 60 minutes. Both these statements are mathematically correct. So how do we know which one to use? Well, that depends on the task that we're given. In this example problem, we are asked to determine the mass in kilograms of a person who weighs 164 pounds. In order to solve this problem, we need the equality that 1 kilogram equals 2.20 pounds. So that tells us the relationship between pounds and kilograms. And the two different conversion factors we can create are that there's 2.20 pounds per 1 kilogram, or 1 kilogram per 2.20 pounds. The way you know which one to pick is, in this case, we want to convert from pounds into kilograms. That means we want to cancel out units of pounds. The unit we want to cancel typically goes on the bottom of our ratio. So 164 pounds, we're going to cancel it out with 1 kilogram over 2.20 pounds. So the pounds in the denominator here cancel out with the pounds in our starting number. We're left with units of kilograms. And so the way we'd solve this problem would be 164 times 1 divided by 2.20 gives us 74.5 kilograms. So that's the mass of that person in kilograms. In another problem right here, we're asked how many minutes are in 2.5 hours. So we're going to use our equality that compares the relationship between hours and minutes. So 1 hour equals 60 minutes. And so we can turn that into the conversion factor, 60 minutes per 1 hour. And so the hours go on the bottom, so we're trying to cancel the hours right here. So 2.5 hours times 60 divided by 1 gives us a value of 150 minutes. And we know that's two significant figures. This is known to two sig figs, this number we start with. This is actually an exact number because it's within the same measurement system. And again, we can know this to two significant figures, 150 minutes. I'd like you to now pause the video and then solve questions 1 and 2 in the activity. Welcome back. Now that you've solved problems that involve a single conversion factor, we're going to begin to string multiple conversion factors together. In this example problem, we're asked how many minutes are in 1.6 days. We don't have a conversion that brings us directly from days to minutes, but we do know that 1 day equals 24 hours, and 1 hour equals 60 minutes. And so we can set up our ratios, our conversion factors here, 1 day per 24 hours, 24 hours per 1 day, 1 hour per 60 minutes, and 60 minutes per 1 hour. How do we know which ones we need to pick? Well, we want to cancel out units of days because we want to get from days into minutes. So we're going to set up our ratio here where we take our 1.6 days and multiply it by 24 hours over 1 day. So the days cancel each other. But it's not hours that we ultimately want. We need to get from hours into minutes. So we're going to set up a second conversion factor now, 60 minutes per 1 hour. The hour is in the bottom. It cancels with our 24 hours up top here. And this leaves us with units of minutes, which are the units we're seeking. So we're going to solve this by taking 1.6 times 24 times 60 divided by 1 divided by 1. And if we round to 2 sig figs, because we have our starting number known to 2 sig figs, these are all same measurement systems, so they're exact. We can only know our answer to 2 sig figs, so that becomes 2.3 times 10 to the third minutes, or it could also be expressed as 2,300 minutes. Either would be acceptable. Right here we have another problem. An injured person loses 0.3 pints of blood. How many milliliters of blood would that be? So we don't have a conversion that goes directly from pints into milliliters, but we can go from pints to quarts, and then quarts into milliliters. So here's our list of possible conversion factors. How do we know which ones we need to pick? Well, it's all based on the unit cancellation. 0.300 pints, that's given to 3 significant figures, and so we'll have to measure that, so that's a measured number. We're going to set up our ratio of pints versus quarts, so the pints are in the bottom, they cancel the pints in our starting number. And then we're going to use our second conversion factor here, 946 milliliters per 1 quart. Our quarts cancel, and we end up with 142 milliliters. Our starting number is known to 3 significant figures, and so I'm going to have to measure that volume of blood loss. So this is 3 sig figs. Our pints to quarts is going to be exact. They're within the same measurement system, the US system, but there's actually a mistake here in the slide. And so 946 milliliters is metric system, 1 quart is US system, and typically going from system to system it's going to involve a measurement. So this should actually be a measured number, and we know it to 3 sig figs because 946 is expressed to 3 sig figs, and the 1 is exact right here. Ultimately, we have 3 sig figs, exact 3 sig figs. Our answer is limited to 3 sig figs, 142 milliliters. I'd like you to now pause the video and complete questions 3 and 4. Let's talk about some more advanced problems. Density can be used as a conversion factor as well. Density is typically expressed as mass over volume. In the example problem, we have a 0.258 gram sample of HDL, which is a type of cholesterol, and it has a volume of 0.215 cubic centimeters. What is our density in grams per cubic centimeter? So how do we solve this problem? It's actually pretty simple. We take our mass, and our mass is 0.258 grams, and we divide it by our volume, 0.215 cubic centimeters. Crunching our numbers here, we end up with 1.20 grams per cubic centimeter. We can express it like this, or like this. These are both acceptable methods of expressing it. So our density we can actually use as a conversion factor to solve problems. And in our example right here, if the density of milk is 1.04 grams per milliliter, how many grams of milk are in 0.50 quarts of milk? So again, we get our equalities from that equations and constants file. We have 0.50 quarts right here. That's measured. Someone had to measure our volume of milk, and that's known to 2 sig figs. And 946 milliliters per quart. We use this conversion factor here. The quarts we want to get rid of, so they go on the bottom of our ratio. They cancel the quarts here. And then 1.04, this should actually be grams here. The authors made a mistake in the slide, and unfortunately it's an image, so I can't fix it. 1.04 grams per 1 milliliter. This is measured, so I would have to measure the density of milk. This is known to 3 sig figs. And so if we take our values, we have one known to 2 sig figs, one known to 3 sig figs, another to 3 sig figs, but our answer is limited to just 2 sig figs. We're always limited by our lowest amount. To solve this problem, 0.50 times 946 times 1.04 divided by 1 gives us 490 grams of milk. I want to make you aware that percentages can also be used as conversion factors. And so, if, for instance, we have a food that contains 18% by mass of fat, that would mean we have 18 grams of fat for every 100 grams of food, or 100 grams of food per every 18 grams of fat. How do we know which one to use? Well, again, it just depends on the problem we're solving. If we want to cancel out grams of fat, that would go on the bottom. If we want to cancel out grams of food, that would go on the bottom. I'd like you to now pause the video and complete questions 5 through 8 in the conversion factors activity, and now might be a good time to actually go back to that sig figs activity and complete the final question there. And once you complete the conversion factors activity, please go to the discussion board and interact with your team.